Okay, so we've got these terms to look at. We were talking about that this polynomial just happens to have three terms. This is the first term, second term, third term. They've put them in order. One of the things that you'll have to do on the little assignment that I made you is to take a polynomial that is not in standard form and rewrite it in standard form. And all you do is just rearrange it. Because be careful, and we'll talk about over here when we get to our notes here in just a second. There is a difference between the degree of the polynomial and the degree of the term. As a matter of fact, I think what I'm going to do real quick is I'm just going to run over here and I'm going to copy this little thing right here and bring it over here and stick it on this page so we can kind of see them both at the same time. Okay, so standard form, what did it say when we were talking about it over there? It said that standard form was going to be when the exponents are in descending order. This is an example of standard form. Okay, here's an example of this polynomial. It's the same polynomial, but it's not in standard form. This polynomial right here and this polynomial right here are the same polynomial. This one is in standard form because the exponents are written in descending order. The fifth is the biggest exponent, so it goes first. The 2 is the second biggest exponent. Remember, this exponent is x to the 0, okay? So 0 is smaller than the 5 and the 2. So this is in descending order, so it's said to be in standard form. This one's not in standard form, but we could certainly rearrange it and put it in standard form. Okay, so the degree of the polynomial is different than the degree of the term. This term right here is a 5th degree term. This is a 2nd degree term, and this is a 0 degree term, which can also be called a constant. Okay, then we tell the degree of the polynomial. That is the degree of the highest degreed term. So you have to be able to tell the degree of each term. You have to be able to find the degree of each term in order to find the degree of the polynomial. This term is 5th degree, this term is 2nd degree, and this term is a constant. And since the 5th degree is the highest, we would say that that is the degree of the polynomial. The leading coefficient is it's the real number that is in front of the term with the highest power. Okay, again, you should be writing this down and on that piece of paper that I gave you. If I didn't give you the piece of paper, then you should just be writing it in your journal. I do have a piece of paper to give you, but it's not important. It looks exactly like you see right here. Okay, so each term has a name based on its degree. So this term right here, we would just call it the 5th degree term. This one right here would be called a quadratic term. And I believe if you look back over here in your book, they're kind of telling you right here, if the degree is 0, it's called the constant term. If the degree is 1, it's the linear term. If the degree is 2, it's a quadratic term. If the degree is 3, it's the cubic term. If the degree 4, it's a quartic term. Although usually after cubic, we don't name them anymore. We just say 4th degree, 5th degree, 6th degree term. And again, the whole point in naming the term is so that we can name the polynomial. Okay, so again, the polynomial, the name of the polynomial will be the name of the highest. I don't know why it's having problems. Of the highest term. The name of the polynomial will be the same as the name of the highest term. Term name is based on exponent. Okay? So, one of the things that this lesson is highly vocabulary. I mean, that's pretty much all it is. It's just a bunch of vocabulary terms. But one of the things that we're supposed to be able to do is look at a polynomial. First of all, tell me all those things about it. What's the degree of the polynomial? First of all, is it a polynomial or not? What's the degree of the polynomial? What's the leading coefficient of the polynomial? How many terms does it have? And then several of the things that we are going to be needing to know about that polynomial is going to be based just by looking at it. So one of the things you can tell is what the y-intercept is. The y-intercept is always going to be the constant term. Okay, so the constant term is going to be the term without the variable, or the x to the 0 term. That's going to be what your y-intercepts. The number of x-intercepts that you have. And we'll talk about this in much more detail in a later subject, in a later lesson. But if it's a fifth degree polynomial, then you can have at most 5 x-intercepts. Now, I am not saying that you will have 5 x-intercepts, because you may not, because we know some of these could be imaginary, but we can have at most 5. A fifth degree polynomial cannot have any more than 5. It might have 5, but it can't have more than 5. We're also going to be looking at turning points. I'll show you what that is in just a second when we go back and look at a graph. A turning point. This one right here can have at most 1 less than the degree of the polynomial. So for this one, it would have at most 4. This one right here, the maximum number of x-intercepts will be n, the degree of the polynomial. Okay, because remember back here when we were looking at this polynomial written in this form right here, n is the degree of the leading term. Okay, so it's the highest power. So that's why it can have n x-intercepts, and it's going to have 1 less than that. The number of turning points can be 1 less than that. So if you understand what the letter n is, then all you have to put right here is that n is the maximum number of x-intercepts, and n minus 1 is the number of possible turning points. End behavior. We're going to get a whole new sheet, probably a whole new video for end behavior, because end behavior is exactly what it sounds like. It's how the graph is behaving at the ends, but it's the notation that tends to get students confused about end behavior. So when you come over here, and one of the things that we're going to do next is we're going to take this problem right here and we're going to graph it, but and we're going to talk about its end behavior. But if you'll go ahead and scroll over here to this page right here, you see how they're talking about end behavior, the end behavior of a graph. Yeah, I know I was running out of time. Got less than 30 seconds. So this will be what our next video is about, over end behavior, okay, and how to write it. It's not a difficult concept to talk about, but it is sometimes a difficult concept to write about because of all this notation. But we'll talk about it next, okay?